Assalamu alaikum. I'm Engineer Hamna Shakil, and in this video I will be explaining these two formulas that are given in the ASTM C469, and I will be explaining what is meant by all these terms given in the formula of modulus of elasticity and Poissons ratio. So the formula for modulus of elasticity is S2 minus S1 divided by epsilon 2 minus 0.00005. In this, S2 is the stress corresponding to 40% of the ultimate load. S1 is the stress corresponding to the longitudinal strain, epsilon 1 of 50 millionths, and epsilon 2 is the longitudinal strain produced by stress S2. And for Poissons ratio, the formula is epsilon T2 minus epsilon T1 divided by epsilon 2 minus 0.00005. Where epsilon T2 is the transverse strain at mid-height of the specimen produced by S2, and epsilon T1 is the transverse strain at mid-height of the specimen produced by S1. So in these two formulas, we can see that there are 2 points, point number 1 and point number 2. So point number 2 is basically limited by the 40% of the ultimate load. Point 1 is limited by the longitudinal strain of 50 millionths. So let's move on to the plot of our data and see where these 2 points lie on the graph. So this is stress strain curve for concrete cylinder. This point here, it shows the ultimate strength of the cylinder. So the 40% of the ultimate load is point number 2. So the stress at this point is S2 and the strain at this point is epsilon 2. Similarly, corresponding to S2 and epsilon 2, there will be another value of the strain, that is lateral strain, and that will be epsilon T2. So this is how you find this point number 2, that is 40% of the ultimate load. And for point number 1 is limited by a value of strain, a value of longitudinal strain of 50 millionth. So here you are having a value of 0.00005, and that will be your epsilon 1, and the stress corresponding to epsilon 1 will be S1, and the transverse strain corresponding to this stress and strain will be epsilon T1. So let's move on to our Excel sheet and extract these values from the data.